Okay, this is supposed to be week 5. Let's just review what we have talked about already. Just very quickly, I guess for your benefit. Yeah. So first, just need to cover that. Yeah. First, we have talked about compose and query. I assume that's not an issue.
Yeah.
Then we talk about foldables and array, where you do reduce and you traverse array into different things that are kind of a silo on the side that we talked about. But the mainstream kind of course is focused on starting with functor. Functor has a map method on any functor which makes the functor. It obeys certain laws. For example, array is a functor. Okay? And we talk about different functor like maybe. We talk about either as a functor. We talk about promise as in a functional promise, not ES6 promise. What else we talk about? Yeah. Okay, I've been using list as an example here. Very quickly go through certain things. Let's review again. What's the type signature for map? Yeah. So F. What's a function, right? A function from what to what?
Nothing.
Take a function first. Take a function first. So we have a to b, which is a function, and we have fa and to fb. So in the sense of an array, if we're using lambda map, let's say a plus 1, that's this function, and then say array of 1, 2, it will give me array of 2, 3. So what it means here is this f here for array is just array, right? So the type signature for this map is a to b. Here a to b is int to int. So this is type level. This is runtime or term level. So this function int to int, I have array of integer here, right, and produce array of integer. I can do to say a larger than 1. What does that mean? That means this b will be below here. Okay. So to generalize that, a to b is this function, type A to type B, and the map is acting on an array of type A and produce array of type B. So the concept of a container is very obvious here. Array is acting as a container. When you recognize that array as a container as functor, that means any function work inside this container with the same type. Because the map now you can inside this can work inside the container, right? Because this function does not take array of A, it only takes A. A is type inside array. There is other functors as well, so that means we denote that to say other functors, right? So this is true for all the functors. We call this kind of type signature in this thing. This thing is a type class. That means array is a type class of functor. What does functor tell you? It tells you it needs to implement this method. It's like interface in object-oriented programming, but there's a subtle difference that I won't go into. But you can think of it as a specification for functor. For array to be functor, it needs to have this function to acting on the array, like this type signature. And then we talked about another thing called applictive. So it is a functor as well. So that means it has a map can act on it. So applictive functor, you need to implement this function instead. And anyone knows the type signature here? Remember those things, okay? Let's review the map again to see what's the difference here. Okay.
A to B.
A to B, yes. All right.
F is
Yeah, cool. All right. So here, for AP, it acting not on the value of a functor, but the functor itself contains actually a function.
So
Remember?
FA to
Sorry?
FA.
It's actually putting these functions inside the functor. Yes. So the function inside a functor, and you give a functor contains a type matching up this input of this function, and it will produce FB. In Lambda, the AP can acting on array. For example, you have a function say sorry. A plus 1. Same example, a bit different, right? Now this function inside the array, then 1, 2. This gives me 2, 3. Sorry. Yeah. Same result, but now we can use a function inside the same functor to acting on a functor containing some value of the same type of this as the input for this function, and then produce FB here. So that's the difference with applictive functor and functor. It has this AP function. Okay, and then we had a bunch of exercise, and we touched on this concept of monads. Okay. The monad. A monad is a type class. Sorry. That one is vertical, so it's covering more stuff here. So it's a monad. Monad needs to implement in JavaScript Fantasyland. Spec needs to implement this function chain. Now let's compare again to map. Right. We have A to B. That's the function FA to FB. Right. The chain, what it does is something's different here. A to MB, MA, MB. Now, like it's M here instead of F. It's just semantic is different, but it means the same thing. I can just say f, right? It's the same, but we like to, because it's monad, so we say it's n. Using array as example, well, let's examine this type signature first. The only difference is here, right? So this function here does not produce a plain value. It produces a type of value inside the same functor. Right? So that's the major difference here. For example, render has this chain function. What it does is, okay, let's say, same example, a plus 1 as integer to integer, right? Yep. So if we use array as an example here, you need to put array here to fit that type signature. Integer to integer inside a array. Okay, so now I have 1, 2, then this produces 2, 3. What does it do? If you do map here, what's going to come out? If you do map here, what's the result here?
Array 2, array 3.
Array of array 2,
And array 3.
array 3. Okay. So the type signature for that would be, if we use f as a functor, fb, right? If this produces fb, some context, then we'll be doubling the f here. Right? So chain is a function you need to implement for a particular monad. It tells you this particular type has ability to collapse 2 layers of context, the same 2 layers of context, to 1 layer. So, yeah, that's one of the intuition behind monad. Okay, so now for this class, we're going to talk about more monads. And by the way, monad needs to be applective and needs to be functor. Let me use a laptop here. All right. Okay. Anyone can see that? See that? Yeah. Is it too small?
Yeah, it's small.
Okay, increase it.
Here.
Okay. All right. The first one is radar. Radar monad. We have the radar example file here. This monad is to solve a particular problem of rating or getting environments. Let me demonstrate that. Let's say you have data like this. You have an array of 3 records here. As ID, blah, blah. It can act as a fake database storage. Okay. And then I have this function called database connection, which is let's say it's your ORM. It has get on there, get by IDs. So this is actually a good chance to review what we learned about Lambda as well. So here, it gets the data and then find the ID equals to the ID passed in. So find a particular record and return it. And get by IDs, it will actually filter through the data using a function that takes the IDs you passed in, which what it does is it finds
ID equals to the ID you passed in, and using that as filtering. That means if you pass in array of 2, 3, it will give these two records out. Okay? That's very straightforward. Yeah. Any questions, just ask. Okay, that's just a bit of a context here. Now I have two functions. Before I go further, I've wrote all those things in the same file, right? But normally you will have your database connection generated by a singleton, pattern file, or maybe not, somewhere you import, and you have your bunch of utility functions to get, a user, or some, according to a business logic, you have utility functions, and to fire queries to the database. Now these two functions are those kind of utility you fire queries to the database. What you require is a connection and an ID. You just calls it. This one, it requires a connection and IDs, and of course the get by IDs. Yeah, just two functions. That's it. And the business logic requires you to say, first, according to the ID 1 I passed in, I can get the user out. Right, that's get by ID, database connection, and ID. Very straightforward. And then once I have that user, I'll get his friends. You may think I can possibly in a SQL database get these, out at the same time. But let's say you have like separate databases you want to connect to, but here it's just a simplified kind of construct here. So you get your list of friends based on the single ID you passed in. Let's have a look what we got here. Let's just comment this out. So we have the radar examples. Yeah. So it's ID 1 passed in and finds that particular instance of the user with ID 1 and gets the friend with that user. Okay. Now, the question is, in functional programming, you're always asking this question: how do we compose that verb? Right? These two things, without passing, you have a query function basically, right? Two query functions. How do we compose them? We use it like this with some variables and find stuff. That's all fine, but how do we compose? How do we compose and make it more elegant? Now, here's option 1. Option 1 is because they are query, you just pass database connections generating another two functions. Right? And then what you do is you compose the first function, which is get by ID, and then you say, I have a friends key on it. I want the array of that friends, so I do prop. That's ramdev's function, and then based on the ID, I pass to this function. Right? I compose them. That's option 1, and I won't run that because it's fairly simple. You will see later. It works. Now, but if you examine closely, what we have here is actually an environment that does not change. The database connection will not change. Right? Yeah. That means if you have 10 utility functions like this, you're going to generate 10 of them like this. One note is you have to write those utility functions like this with connection passed in, because when you test them, you possibly need a fake one passed in, right? So the dependency is not fixed. That means if you have 10 functions like this, you need a 10 function like this in order to compose them. We have a pattern in functional programming called the radar monad pattern. What we do is, let's say get by ID, for example. let's just examine what happens here, and then we go to the details how it's implemented. We say, I have this radar type. I have this property on it. Once you .ask, you have something in hand to say later on, it will give me the environment. It does nothing for now, but later on, when I run it, it will give me a connection. It is a functor. Once you do .ask, the functor encapsulates the value of your environment. What it means, let's say, remember array is a functor, right? So this means this array as a functor encapsulates the value integer of type integer. Right? These two lines give you a functor encapsulate a value which is your environment. Later on, you will pass that in. Okay. If you have a functor, you can map on it. And I already said that the environment later on you are passing is the connection. So what you can do is use that connection like this. Okay. It's the same of get by IDs with radar. It asks for the connection, and then with that connection, it calls that function, the utility function. Yeah? Okay. All right. So that's a bit of a magic when you're looking at it. This mainly just that. It basically just coming from nowhere. It has no reference to the connection itself. But somehow when you map it, a connection comes out. Yeah? That's because this is composition. That's because when you run it, you pass the connection in the end. And when you compose it, you don't reference the connection at all. What you do is, first you call this get by ID with radar. The type signature is, ID is the integer, right? And then you produce a radar of, what's the thing here? What's the thing encapsulate? Looking at this function, whatever that return is whatever it encapsulates. Right? It will be a, let's say, it will be object of ID, name, and friends, right? So it's like ID, name, and friends. Friends is optional. This is not valid type signature, but you get the idea. Right? The radar not only encapsulate that, it will have an environment here. That environment is actually a connection, but we haven't given that to you. The type signature is like this. If the type for that environment is connection, it will be like this. Yeah. And the compose K here, we mentioned that very briefly earlier. What does it do? It compose, the K stands for classly. Remember that? Okay, so let's go through that briefly. Let's say you have a function A, what it does is x plus 1 in an array. You have function B, x plus, well, x times 2. Right. These two functions are very similar to those two functions, right? It just arrays, it returns a value inside the functor. Okay, so we call those functions classly arrows. I forgot how to spell it. Well, arrows, I know. Is it like this? Yeah. Well, name doesn't matter. Once you have those two functions, how do you compose them? If you just do compose A and B, it doesn't work, right? Because the output here is array. Yeah, exactly. Can't do that. Can't do array times 2. Well, you can in JavaScript, but it doesn't make sense. So what you do, you put a K here. Then you can compose them. What does it actually do is, right? Because when you're mapping it, you have 2 levels. You want to collapse, then you have the chain here. Yeah? To save you typing this, because you may have multiple of them, right? Chain C, which returns array of something as well, and then you just do compose K. If A and B and C and D all return the same functor, if a different functor, you can't do this. So here, it means every function I compose here will return a radar functor. Right? Here, it return array as a functor. Right? Here, every single function I have here will be returning a radar functor. Okay. So that means this part returns a radar functor. That means be aware that when you call this A here, right, you have array of a number. Right? The B doesn't receive array as input. Instead, it receives the number inside that array. So for this function, the input will be this. Okay. So the input for this function is that to returns the same functor, connection, and array of integers, right? The IDs.
What does read of do?
Read of is the same as array of. Array of 1 is equals to array of 1. So radar of 1 will be 1 inside the radar, basically. So the thing you map over later will be 1. Yeah. So radar of 1 dot map, and you do a function here. That x will be 1. Yeah, that x here will be the 1 here. All right. So after this, I have this integer inside array, inside a radar functor. So that means here it receives array of integers input, and it gives me same functor, remember, and right. If you don't understand, just ask. Right? Otherwise, I'll keep going. And here I have no mention other than there's a type here from nowhere. There's a connection passed in. Right? But after I compose it and I give it an initial value 1, which is this integer here, the return type will be this, right? Once I call it with 1, the return type will be this. Yeah? Then what I do, I call .run on it to pass the environment. Once I call .run on it, all the function inside will be called with this connection. That means here .ask will actually contains the connection eventually. If I don't run it, nothing happens. No function is getting called.
So kickoff always needs a database connection.
Yeah.
So this is kind of like a lazy
Yeah, it's lazy when you look at it, because it's very often people just in monads you dot wrong something. You're building up your computation, and according to your design idea here, your design is to say, I want environment to be separate. I want environment to be run, passing when you run it. That's your design, right? So I build up my computation, and then I'll call run with my environment. Then my computation will run. Okay? So hopefully you get a slight intuition of functional programming is to model how you're programming. It's not like patterns. It's not patterns in your code. You do dependency injection or whatever. It's model how you actually coding. Is to formalize the concept of environment here. Right. So let's have a look at how is radar actually implemented. Let me drag it to here, and then put radar here. That's it. That's the radar implementation. Very small. Let's start with this. Radar, what this line tells you is I produce this type called radar, the name called radar. And when I construct it, I need to pass a function called run. So that means, let's look at what's the ask, right? The ask is used here. Ask itself is the object. It is passed with identity. That means radar, well, first thing first, dot run is the function here. Here doing equals identity, right? Let's know that, yeah? Okay. That means if I run it with 1, what's the value here?
1.
Yeah, that's 1. Yeah? Yeah. That means whatever I passed in, it gives me identity does that, yeah? Okay. So, let me get that back. Yeah. All right. Radar is also a applicable functor. I said earlier, any monad is a applicable functor. So, well, you need to define AP on it, but the of function on the class, on the radar class here, is this. What it does, radar of 1, run, sorry, 2, what does it come out? What's coming out here? 1, right? Yeah, yeah. Because it's always return A.
1.
Yeah.
Should be 1 here.
Yeah.
Always 1.
Yeah. So the run here is always 1.
Mm-hmm.
Yeah. So it will return you 1. So with these two things, you look at it, right? The ask, what does it do? Let me just write it again, so you have a very clear understanding. The ask will put environment into the place that the functor holds. Radar holds 2 values. One is environment, you pass at the end, right?
Mm-hmm.
The other is the functor contains that value. That value is the other value, right? So here, what the ask actually doing is, when you pass environment in, that environment will be put into the functor. Okay, environment is not the value inside the functor. You need to be clear of that. And here the of the value inside the functor here, the functor actually encapsulates the value here is 1, not 2, right? 2 is the environment you're passing. Here we just don't use it. Yeah? Okay. Of course, map. It's a functor, so I need to implement a map. What does map do? oh, sorry. Map takes a function, right? So let's write a type signature map. It takes a, well, here is a method, not a function. So I write the value of this first, the type for this, and which is radar and environment, and your value inside. And then because it's this, so I use tilde, a to b, which is this function you passed in to map, and to radar e b. Yeah, that's the type signature here. This is the context, is the container, is the functor. Yeah. This is the value encapsulated in that functor. This is crucial. Like people always, when you first go into radar, you're sort of thinking the environment is the thing it encapsulates. No, it's not. The environment is actually part of the functor, the container itself. The value inside is actually that thing and this thing. Yeah? So with that knowledge in mind, how do we produce that for this function? That is, I create a radar, right? Radar is a constructor itself. So, so we also use radar here, right? Radar is the constructor itself. And radar takes a run, which is a function. Yeah. What's that function? The function is whatever value we passed in as environment. I run it and then pass the result to F. Yeah. So this run, based on your combination of ask, map, chain, blah, blah, and dot run, it will pass the environment in, do all the calculation for you. With that value spits out and pass to this F. Because it's a radar, so it passes to radar as a function, which takes the environment again. Later on, it will pass it. It's sort of thinking ahead. When you have the environment, what you do, right? But you don't have. What do I do? I put a function here. Yeah. Chain. The type signature for chain is right. So collapse the context. The same context here, same context here, same context here. The only difference is, I gotta run it multiple times to reduce context. It's a radar. I'll make it clear here. Okay. Make it same. Okay, this part is the same, right? These two parts. It's just mapping, but to reduce another layer of context, it runs it. So going out of the radar. Right? Every time you run, you pass environment, the value comes out. Because the value inside is another radar, so you have a radar. Okay. Problem? Huh? So let's compare it. Well, let's look at the implementation of this example again. Yeah. Radar.ask. What does ask do? whatever environment you pass in the end will give you that. So that means so the type signature is radar environment. Yeah. So you give me the environment, that's the context, and I'm putting environment into the context. So EE. That means I'm mapping on this E now. So I get the environment, which is the connection I pass in the end. Yeah. So I'll keep going. So that's E. And that's give me value. So after this line, radar environment, the context doesn't change at all. What it changes, it gives me this thing. Right? Is that clear? Yeah. Context doesn't change here. The mapping changes that E. Right? That's the context. That's the value inside. Yeah. Okay. Similar stuff here. It just this gives me an array instead of a single object like this. Right? We can easily write it. Radar E, right? And then here it will give me that. Yeah. Yep. Okay. Yeah, this is the array stuff. Get rid of it. So hopefully, with those kind of things, it's just composing them. Yeah. That is equal to yeah. Oh, sorry. Yeah. Is that clear? So in order to use compose K, this part needs to return, this function needs to be a classly arrow, right? But prop friends does not produce a radar. So I have to do a radar of here if I want to use compose K. It's a bit of a tricky situation there. Is this clear? All right, let's take a break and we'll go on to writer afterwards.